Hello children, I'm Sonal and today we are going to start a new chapter in geometry which is triangles. Alright, let's go ahead. Now, before we start with this chapter, we are going to understand the basic theorem of this chapter which is known as basic proportionality theorem. It is also called as the Thales theorem. In this video, we are going to understand what this theorem says. The proof of it, we will do it later. So let us see what is basic proportionality theorem. It says that if a line parallel to a side of a triangle intersects other two sides in two distinct points, then the other two sides are divided in the same ratio by it. So let's see what does it mean. It says that we have a triangle. Yes. So let's name the triangle ABC. Now it says that if a line is parallel to a side of a triangle, so we can pick up any side of a triangle. In this case, in this diagram, I'm going to pick up side BC as my main side. So I'm going to draw a line which is parallel to my side BC. So here I draw a line, right? And it is going to intersect my other two sides apart from BC. So that is side AB and side AC, isn't it? So the intersecting points are point D and point E. So what does it say? It says that if a line is drawn which is parallel to the side of a triangle, then it divides the other two sides in the same ratio. That means in this triangle ABC, line DE is parallel to line BC. Then what does the theorem says? It's going to divide the other two sides in the same ratio. When we talk about ratio, how do we write, children? We write AD upon DB. Isn't it? It's the same ratio. So it's going to be AD upon DB should be equal to other side, that is AE upon EC. So our basic proportionality theorem or the Thales theorem says that a line which is parallel and intersects the other two sides in two distinct points divides that line in the equal ratio. AD upon DB is going to be equal to AE upon EC if DE is parallel to BC. That's the basic proportionality theorem. Alright children, isn't that easy? Now, let's understand an example based on this. So, in this example, we are going to take this figure. Okay? So, this is triangle PQR. Now, instead of the base BC, we have the base here as PR, which is on the upper end, right? And the line MT is intersecting PQ and RQ at two distinct points, M and T respectively. So, MT is parallel to PR, right? So, what is my basic proportionality theorem says? Yes, you are correct. It is if line MT is parallel to side PR, then my QM upon MP is going to be equal to QT upon TR. So how do we write? We write in triangle PQR, MT is parallel to PR. Therefore, we are going to write the ratios, that is QM upon MP is equal to QT upon TR. And what is the reason, children? Yes, it is by basic proportionality theorem or by Thales theorem. Yes, very simple, children.